Hello friends, how are you? I hope all of you must be fit and fine. Friends, I once again welcome all of you in my YouTube channel. So friends, I believe that you all must be watching and loving the videos which I have already posted and which are currently live in YouTube. So friends, if you find those videos useful, I will request you to kindly like and share those videos among your friends and colleagues and do subscribe my channel. So basically I will be covering the chapter 1 of second guidebook. So friends, number 1, combustion. As you all know and you must have read, what is combustion? So what is combustion? Combustion is burning of fuel in presence of air to produce energy. Now as you all know, what constituent of air takes part in burning? So for burning of fuel, oxygen is must, because without the presence of oxygen, burning cannot take place. So I can rewrite this statement as burning of fuel in presence of oxygen to produce energy. Now we will look at the various components that are present in fuel and which takes part in the combustion as the fuel gets burnt. So the primary constituents of the fuel. So what are the main constituents of the fuel that have a key role in the combustion and hence in the production of energy? The first constituent of the fuel that is involved in combustion and have a direct bearing on the amount of energy produced is carbon, which is denoted by C. As you have read in your chemistry classes that carbon is represented by C. Now the another constituent of the fuel that takes part in combustion is hydrogen. Now the next component of the fuel that takes part in combustion is sulfur. Now these are the main three components that takes part in the combustion of the fuel. There are many others which I will take care when I will be explaining the example whereby I will deal how a combustion of a fuel actually takes place. Now we will see how the combustion of these three components takes place. So as I have already told you that combustion is nothing but burning in presence of oxygen. Now we will see how the combustion of these three components takes place and what are the various reactions that are involved in the combustion of these three components. Now you can see here the combustion of carbon involves two reactions. First one is this one and second one is this one. We can say when the carbon is burned in presence of oxygen, CO2 is getting formed. So this is carbon dioxide. And when the carbon is burning in presence of oxygen, also CO can be produced. And what is this CO? This is carbon monoxide. Whenever the combustion of carbon takes place in sufficient amount of air, or you can say in sufficient quantity of oxygen, then carbon dioxide, that is CO2, will be produced. And if the combustion of carbon takes place in insufficient supply of air, or I can say in insufficient supply of oxygen, then carbon monoxide, that is CO, is getting produced. So when you are having sufficient supply of oxygen, then the combustion of carbon results in the formation of carbon dioxide along with the production of 8084 kilocalorie of heat energy per kg of carbon. Similarly, if you are having insufficient supply of air or oxygen, so you can say that the combustion of carbon will result in the production of carbon monoxide and the release of heat energy will be 2430 kilocalorie. Now how the supply of this oxygen can be insufficient? Suppose you are having your engine or your turbine whereby heat energy is produced by the combustion. So generally in the turbines or in the engines you are having an air filter, so that the air which is ultimately reaching to the combustion chamber is free from all pollutants. So if you are not maintaining that air filter properly, suppose the air filter is getting choked and you have not carried out proper maintenance of that filter, so what will happen? The amount of air that is passing through the filter will be less because of the high differential pressure that has been created around the filter, because the filter will not allow the air to pass through, as the filter has been choked because it has not been cleaned regularly or because the preventive maintenance has not been carried out. So it is one of the cases where you can have insufficient supply of oxygen in your combustion chamber of your engine or whatever medium you are using for the production of energy from the combustion of fuel. So one thing you can very clearly see from this equation 1 and 2, that if the presence of oxygen is less, then it is having a direct bearing on the amount of heat released. Here the combustion of carbon results in the production of 8084 kilocalorie of heat energy per kg of carbon. Here the combustion of carbon is resulting in the production of 2430 kilocalorie per kg of carbon. So you can easily see there will be decrease in the production of energy if the quantity of air supplied is not proper, and how much less energy will be produced can easily be calculated as second minus 1, or you can say 8084 kilocalorie minus 2430 kilocalorie, which will come as 5654 kilocalorie. So you can say that with the production of carbon monoxide you have lost this much energy. Now you all know why the combustion of fuel is taking place. The combustion of fuel is taking place to produce the energy. Now in case if there is insufficient supply of air and you want to generate a fixed quantity of energy, then for the production of energy you have to consume more fuel, because your energy generation has been decreased because of the poor supply of air. So it is very essential that we should supply sufficient quantity of air so that proper combustion takes place and we can get the maximum amount of heat energy that can be produced by the combustion of carbon present in that fuel. Now you can easily see that the combustion of hydrogen present in the fuel will result in the formation of water along with the release of 28,922 kilocalorie of heat energy per kg of hydrogen. This means when combustion of 1 kg of hydrogen takes place, 28,922 kilocalorie of heat energy will be produced. Similarly, you can say that the combustion of sulfur will result in the formation of sulfur dioxide along with the release of 2,224 kilocalorie of heat energy per kg of sulfur. This means when combustion of 1 kg of sulfur takes place, 2,224 kilocalorie of heat energy will be produced. So from the point of view of the exam, you have to remember these 4 combustion equations, because these 4 equations will be used invariably in all the numericals and at many places, as we will see subsequently. So friends, whenever you are dealing with the chemical equations, do remember one of the most important things, and what is that? The equation that you have formed must be balanced. Now what is a balanced chemical equation? As you must have read in your chemistry classes that this can be set at the left hand side of the equation and this is the right hand side of the equation. So as per the mass balance, whatever be the constituents on the left hand side of the equation, the same should be there on the right hand side of the equation as well. Now you can see here the quantity of carbon is 1 and the quantity of oxygen is 2, and here in CO2 the quantity of carbon is 1 and the oxygen quantity is 2. So the equation 1 is balanced chemical equation. Now we will look at the second equation. Here you can see the quantity of carbon is 1 and oxygen quantity is 2 on the left hand side. On the right hand side the quantity of carbon is 1 and the quantity of oxygen is also 1. But here the quantity of oxygen is 2. So what can I do? I can either make this quantity as 1 or I can increase the quantity of oxygen present here up to 2. So how it can be done? I will multiply by half on the left hand side. So now the equation is getting balanced. Suppose I am balancing this equation by multiplying the factor of half to this oxygen on the left hand side, then I would have get the equation as this. Now suppose I will multiply this equation by a factor of 2, what I will get? I will get 2C plus O2, that is equal to 2CO. That is what I have calculated here. So either way you can do whatever way you like, but the only thing is that the component or the constituents on both the sides of the equation must be balanced. So now my equation number 2 is also balanced. Now equation 3. As you can see here in equation 3, the quantity of hydrogen in the left hand side is 2, the quantity of hydrogen in the right hand side is 2, so the hydrogen is automatically balanced. The quantity of oxygen at the left hand side is 2, the quantity of the oxygen at the right hand side is 1. So what I need to do, I will multiply here with 2. Now what will happen? Our oxygen will get balanced, but now the hydrogen quantity on the right hand side has become 4. 2 into 2, 4. So what I need to do, I need to multiply here also by a factor 2. Now my equation 3 has become balanced equation. Now equation 4. The quantity of sulfur on the left hand side is 1. The quantity of sulfur on the right hand side is also 1. The quantity of oxygen on the left hand side is 2. And the quantity of oxygen on the right hand side is also 2. So we can say that this equation is automatically balanced. Now do remember, these are the 4 combustion equation that takes place. But suppose your fuel is not having sulfur in itself. So what will happen? You are not requiring this equation. So this equation will not be considered. Suppose in your fuel you are having no hydrogen, then you will not consider this equation. So as per the constituent of the fuel, you have to consider the combustion equation. Now friends, what are the various combustion products that you can get as the combustion of the fuel takes place? So suppose you are having carbon, hydrogen and sulfur in the fuel, which I have considered as an example. So what are the various combustion products that you will be getting? Now the first combustion product that you can get is either CO2 or CO, either carbon dioxide or carbon monoxide. That is, if sufficient quantity of air is supplied, then you will be getting carbon dioxide as one of your combustion product, and if insufficient supply of air is supplied, then you will be getting carbon monoxide. The next combustion product you will get is water H2O due to the presence of hydrogen in fuel. The next combustion product which you will get is sulfur dioxide due to the presence of sulfur in the fuel. The next combustion product which you will be getting is nitrogen. Now you may wonder from where this nitrogen is coming from, because neither nitrogen is present in the fuel nor you have supplied it from anywhere, as you can see from the combustion equation. But remember, for combustion what we are supplying? We are supplying air. Now friends, you are very well aware of that for supplying the oxygen you are actually supplying the air. And what is air? Air is 77% nitrogen and 23% oxygen by weight, and air is 79% nitrogen and 21% oxygen by volume. What is the difference between these two? Suppose we are having 100 kg of air, then we will say that in 100 kg of air we have 77 kg of nitrogen and 23 kg of oxygen. And suppose if I say we are having 100 liter of air, then what does it mean? It means that in 100 liter of air we are having 79 liter of nitrogen and 21 liter of oxygen. So this is the difference between by weight and by volume concept. So remember, air consists of 77% nitrogen and 23% oxygen by weight. But when you are considering volume of air, then you will say the air contains 79% nitrogen and 21% oxygen. Now it is very much clear from where you get this nitrogen. So from the air which you have supplied, the oxygen will be used in the combustion, and what will remain? The nitrogen will remain as such, because you are not using nitrogen in any of these reactions. So accordingly you will have nitrogen as one of the combustion products. And the another combustion product which you will be getting is the heat energy, which is the basic purpose of our combustion. So you can see here, this is a tentative list of the combustion products that you can get, it basically depends on the constituents of the fuel that you are using. Now you will get all the combustion products in a form of a mixture. Now you can see here the mixture of all the combustion products can be called as flue gases, and these flue gases can also be called as exhaust gases, as you may be already aware of. Now we can guess few things from the combustion products. Suppose in the combustion products I am having SO2, then it is confirmed that we are having sulfur at the input. So the fuel must contain sulfur. Suppose we are having water vapor as a combustion product, then there are two possibilities. Either there is hydrogen present in the fuel and which takes part in the combustion reaction as per our equation 3, and ultimately water vapor is getting produced, or the other possibility is that the air which you have supplied is having moisture contained in itself, which is directly converting to water vapor. There is no other occasion which can result in the formation of water vapor in your combustion product. Now as far as carbon dioxide and carbon monoxide is concerned, the presence of these two in the combustion products confirms that your fuel is having carbon as its constituents, and generally carbon is the major constituents of any fuel. So friends, now I believe you have got an idea of what is combustion and the concept of combustion. If still you have any query, you can ask your query in the comment section. Now friends, our next topic is calorific value. So what is calorific value? It is a very simple concept. Calorific value is the amount of heat generated from the combustion of 1 kg of fuel. So I can write it as heat energy produced from combustion of fuel. Suppose I am considering the fuel which I have already considered. Now suppose I am having my fuel with the following constituents. That is, my fuel is having 1 kg carbon, 1 kg hydrogen and 1 kg sulfur. So the weight of my fuel accordingly will be 3 kg, 1 kg plus 1 kg plus 1 kg, and I am assuming that I am having proper supply of air. What does this mean? This means that there is no question of the production of carbon monoxide, because in proper supply of air, carbon dioxide will be produced. So I will calculate how much heat energy will be produced from combustion of 3 kg of this fuel. Now you can see the combustion of this fuel will require combustion of 1 kg of carbon, combustion of 1 kg of hydrogen and combustion of 1 kg of sulfur. Now as you know from equation 1, combustion of 1 kg of carbon will lead to the production of 8084 kilocalorie of heat energy. So from the combustion of 1 kg of carbon, the heat energy released will be 8084 kilocalorie. Similarly, from the combustion of 1 kg hydrogen, the energy released will be equal to 28,922 kilocalorie, as you can see from equation number 3. Similarly, you can see from equation 4 that the combustion of 1 kg of sulfur will result in the release of 2224 kilocalorie of heat energy. Now you can easily see that the total heat energy released from the combustion of 3 kg of fuel will be equal to 39,230 kilocalorie. But now again focus on the definition of calorific value, heat energy produced from combustion of fuel. But you have to realize how much will be the quantity of the fuel that we will be considering for calculation of our calorific value. So the quantity of fuel considered for calculation of calorific value is 1 kg. So I can say, what is the calorific value? The calorific value is the heat energy produced from combustion of 1 kg of fuel. Now I think it is very much clear. Now in this example we have seen from combustion of 3 kg of fuel, energy released is 39,230 kilocalorie. So from here, by using unitary method, I can calculate from combustion of 1 kg of fuel how much energy will be released. So we can clearly see here that from combustion of 1 kg of fuel, energy released will be 39,230 kilocalorie divided by 3, 76.66 kilocalorie per kg of fuel. So I can say in the instant case, that is the example I have considered, the calorific value of the fuel which is having the constituents like this will be equal to 13,076.66 kilocalorie per kg of fuel. Suppose the calorific value of any fuel is given as 5,000 kilocalorie. It is very much clear that from the combustion of 1 kg of that fuel, 5,000 kilocalorie energy will be produced. So you should always remember that the quantity of the fuel which is defined for calculation of calorific value is 1 kg. Now friends, calorific value can be of two types: gross calorific value or the net calorific value. So what is the difference in between the two calorific values? Now the difference between these two is the latent heat of condensation. As I have already told you in my previous video on enthalpy, that latent heat of evaporation is equal to latent heat of condensation. Now what is evaporation and what is condensation? Now suppose you are having 1 kg of water at saturation temperature and you are adding latent heat of evaporation, or you can say latent heat of vaporization corresponding to that saturation temperature to that water which is at saturation temperature. Then what will happen? Then by absorbing the latent heat of evaporation, the water which is at saturation temperature will completely turn into saturated steam, which will again be at same saturation temperature. Similarly, if you are having a saturated steam at saturation temperature and if you remove the latent heat of condensation from that saturated steam, what will happen? The saturated water will again form and will be at the same temperature at that of saturated steam. So you can easily realize, if you add latent heat of evaporation, you are converting water to steam, and if you are removing latent heat of condensation, then you are converting steam to water. Hope it is very much clear to you all now. Suppose this is your combustion chamber where the combustion is taking place. So what is actually happening in this combustion chamber? In this combustion chamber, fuel is entering, air is entering, and inside combustion will take place, and whatever be the combustion products that will leave from here. So if I assume that whatever is the amount of water vapor that have been produced is available here only, that is the energy which will be released. What is that energy? Latent heat of condensation. So that energy is available here itself. So the amount of calorific value we will calculate on the basis of our assumption that the energy which is available with this water vapor is available for our use. We will call that calorific value as gross calorific value. If the water vapor which is produced is leaving the combustion chamber along with the exhaust gas, so what will happen? So the latent heat of condensation that will be released while this water vapor is getting condensed, that will not be available here in the combustion chamber. That you will not have the latent heat of condensation available in this combustion chamber if the water vapor leaves with the exhaust gases. So now again, if we are calculating the calorific value on the assumption that the latent heat of condensation of this water is not available with us, so the calorific value calculated is what is called as net calorific value. Now from this explanation, one thing is also clear, that gross calorific value must be greater than net calorific value. And what will be the difference? The difference is the latent heat of condensation. So for the calculation of net calorific value, we need to calculate how much is the water vapor which is getting produced in the combustion chamber. So you know, water vapor in the exhaust gases can be resulted from two sources, as I have already told you. The first is hydrogen in fuel and the second is moisture present in air. So accordingly, there is a relation between gross calorific value and the net calorific value, and accordingly the relation between the gross calorific value and the net calorific value can be calculated as GCV is equal to NCV plus 584 bracket 9 times percentage of hydrogen plus percentage of moisture divided by 100. So this is the relation which is there between the GCV and the NCV. From here, now what is this? What is this quantity? 9H2 is basically the amount of water vapor produced because of the hydrogen in the fuel. M% is the amount of water vapor present because of the moisture. Subsequently, I will also tell you how this figure 9H2 have been arrived corresponding to the hydrogen present in the fuel. Now I hope that the concept of calorific value is very much clear to you all. So remember, the difference between the two is the latent heat of condensation, the water vapor which is getting produced in the combustion chamber. If we assume that it is leaving with the exhaust gas, so the amount of energy that we will get is what is called as net calorific value. And if we assume that the water vapor that has been produced as a combustion product is remaining here itself, or the energy that is available with this water vapor is available in the combustion chamber here itself, so the energy which we will calculate correspond to the gross calorific value.